So for exam 2, we were asked to find equations that can make Pythagorean triples with 1, 5, and 10. So we first want to start out by making our square over there, our square figure. But also in the exam, it's given that C equals B plus 5, or B is 5 less than C. So we know that C equals B plus 5 and B equals C minus 5. So we can create our square figure over there where our sides are B, B, 5, and 5, and we know those entire side lengths are C and C. So we get B squared, 5B, 5B, and 25. We also know that corner over there is A squared, so we can come over here and find. We can come over to this side over here. We can find we can find B, because 5B plus 5B equals plus 25. And we go down the line and we solve and we rearrange and we get B equals A squared minus 25 over 10. And then we know that C is only 5 more than B, so we can just do A squared minus 25 over 10 plus 5. Now here's the tricky part. We need to find A. I know it's already on the board. But we know that A has to be greater than 5, firstly, because if we go over to B, if you plug in 5 for A squared, you get 25. 25 minus 25 over 10. 25 minus 25 is 0, and you cannot divide 0. Okay, but if we plug in 6, we run into another problem. 6 squared is 36 minus 25, and that's 11. 11 over 10 is 1.1. We want full numbers. If you go down the line and we guess and check this, that, this, that, the first number that is acceptable is 15. Because 15 squared is 225 minus 25 is 200 divided by 10 is 20. Anything less than 15, we're gonna get decimals. We only want whole numbers. All right, so we know that means A has to equal 10n plus 5. Now we have our 3 equations. We have listed over there. I'm not gonna say them again. We can create our first Pythagorean triple. So we're gonna use the integer of 1. We go down the line here. 10 times 1 is 10, plus 5 is 15. That equals A, so we have it here. Plug that in down here. For B, 15 squared is 225 minus 25 is 20, divided by 10 is 20. Plug that in here, and then just 5 more. Now, it just seems that we're plugging in numbers and that's how we got it. But there's a way to check. This is a Pythagorean triples after all. So we do Pythagorean theorem. So now we're gonna test it because we know the Pythagorean theorem is A squared plus B squared equals C squared. 15 squared plus 20 squared has to equal C squared. So 15 squared is 225 plus 400, that equals 625. So now we figure out we have to square root 625. And when we square root 625, it is 25. So now we know we have proven that our Pythagorean triples work and that our equations work. Okay, and we go down the line, we got 1, 5, 7, 10, and 12. And these are our Pythagorean triples. So we got our Pythagorean triple for 1 is 15, 20, 25. Pythagorean triple is 5 is 55, 300, and 305. Pythagorean triple for 7 is 75, 560, 565. Our Pythagorean triple for 10 is 105, 1100, and 1105. Our Pythagorean triple for 12 is 125, 1560, and 1565. The Pythagorean triple for 15 is 155, 2400, and 2405. For the final part of exam 2, we are here to do the proof for n of 5 using the blob theorem. So we know the area of a circle is pi r squared. So we make our triangle and we get our sides. We get 55, 300, and 305. Now that's the ABC for last that we used to make the Pythagorean triple, and I showed here the proof just to make sure that everyone knows that it's right. So we make our circles and we get our diameters of 55, 300, and 305 because of the blob, and then we half them to get the radius. So we get 27 and a half, 150, and 152 and a half. So we're gonna leave that over there for now. So now we come here, we do pi times r squared here, and then we plug it in and we get for the circle of diameter 55, we get 2,375 and a couple decimal places. And then over here we plug it in for 150 and we get 70,685 and a couple decimal places. And we add those together and we get 73,061 and a couple decimal places. So that's what we're trying to, this should be equal to that. So we go over there and we take 152 and a half and we plug it into the formula of pi r squared and we get 73,061 a couple decimal places equal, which proves that the blob theorem has proved it, is right, done.